Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, hello. It is time for another episode of the Digital Enterprise Society podcast. Thank you so much for tuning in and listening, whether this is the first time that you've listened or if you've been listening since the very beginning when we started this show 18 months ago with the idea of being a resource for those who work in and around PLM. The Digital Enterprise Society, it is the forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every single week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm good, Tom. It's good to hear your voice. The leaves are all off the trees up here.
I was going to say the winter is quick. Winter is coming to Michigan, isn't it, Craig?
Yes, it is. And I was looking at our guest and yourself there, and you guys are still in summer clothes, and I'm not. I'll just leave it at that.
I'm just going to tell you that it's going to be like 78, 80 degrees in Texas all week long. I'm planning like hikes and going running outside, things like that.
Thanks, Tom.
Hey,
22 tomorrow night. 22
know,
degrees Fahrenheit.
There's not a lot I get
like -6 Celsius.
There's not a lot of times I get to, rub things in people's face, but people who live up north, cold winter, I'll point out that I live in the Sun Belt any day.
We always rationalize it as it's the variety that we like in the Midwest.
That's right. You get 4 seasons. I've heard that.
That's right.
That's right. All right. Well, every single week, besides talking about the weather in Texas and Michigan, Craig and I, we try to bring to this podcast interesting and different interviews and just a lot of ideas that are going to help all the listeners enhance and grow their careers. And today is going to be one of those days. Today we have Matt Lombard, and he is the owner of Dezignstuff. And I joked with him before we got started. I know what you do. You design stuff. So he is an engineer who also writes books about things that fall somewhere between the world of CAD and design. And he's kind of an interesting guy. So Matt, welcome to the Digital Enterprise Society podcast.
Well, thanks for having me.
So what is your background? How did you get started? I know you have a degree in engineering. I think you said, how did you get started? What did you do that led you to where you are today?
Well, I started in music school, and that led me to 4 years in the Navy as a musician. And it doesn't sound related, but it winds up being very related. The Navy got me into RIT as an engineering student and paid the GI Bill. And I found that the creativity involved in music and the analytical side involved in engineering are really a very good match. And the numbers that you're always using in music match the numbers you're using in engineering.
That's kind of interesting. The other thing that when you said I went into the Navy as a musician, that's not something you hear very often. So right. Tell us a little bit about what that meant.
Well, you have to arrange that beforehand. You don't just you don't
like
just
in boot
get
camp.
into the
You
Navy.
don't go, oh, by the way, I play the trumpet.
Yeah. I really don't like hanging over the side of a boat chipping paint. So I'd rather be a musician. Now you got to audition for that, and I went 2 years to New England Conservatory, and so I thought I was going to be a professional musician, and spending 4 years in the Navy said, I really think this is a better hobby than it is a way to make a living. So that's what changed my mind career-wise. But I also think it was just the experience of being in the military for a few years. I don't think that kids, when they're right out of high school, really know how to make decisions about the rest of their lives, and that it gave me an opportunity to do something that was still valuable, but it wasn't the way I was going to spend my career.
So you became an engineer, and how did you get to where you are?
Well, at RIT, I took engineering. I was very interested as a kid in alternate energy engineering, but when I was in school in the early 90s, that wasn't really a thing anymore. Although it's swung back around so that it is now. So I really didn't get to do the type of engineering that I thought I was interested in. But soon after RIT, I went out to California in Silicon Valley. There was just so much work back at that point. You could work for a different company every day of the week if you wanted to. And I worked originally for a bicycle part manufacturer, and we were making electronic devices for sporting equipment. And I was very involved in pressure sensors at that point. And then I changed jobs and went to the pressure sensor manufacturer. And we did a lot of plastic housing design and tooling for testing and setting up equipment. And more than that, I was writing procedures for our ISO certification. So that's really where I started to combine engineering with writing. Was in that job still early on. Then I moved back east, and I went to work for a SolidWorks reseller, and spent a lot of time working with SolidWorks customers and other types of CAD program customers, just trying to solve various problems, doing some sales, doing a little bit of tech support, some training, some implementation, a little bit of process consulting. So I got the whole gamut on that. Did a little time as a CAD administrator, which I found very rewarding work. We implemented a larger PDM system, going from manual file management to a little bit of automation in the file management process, and that's that was very informative and I thought a lot of fun. From there, I just decided that all of the things that I was doing with these other companies were things I could do all on my own. And so I broke away and started doing some consulting, and I was consulting on various types of projects, some design projects, some implementation projects, and some just process improvement projects where a company would have me in and evaluate their engineering system and process, and then I'd make suggestions and tweaks. But while I was doing that, one day, just out of the blue, I got a phone call from an editor and said, how would you like to write a book? I was a little bit stunned, but I just agreed to it immediately. So
that's interesting. So did they know you, or somebody had recommended you? There must be some experience there.
Yeah, I along with all of this stuff, I had a lot of exposure, we could say, on the internet. And this was kind of in the early days of forums, and really before forums came to be, when we were on the on Usenet system. And so
a couple of us know what that is.
Yeah. Yeah, I'm giving away some things about my age, I think, here, but Usenet was comp.cad.solidworks was active starting in I think 96, and it went on for quite some time. But it really was the wild west of interaction online, and the early days of social media before all this organized Facebook and Twitter and stuff. But
so your book was easy to do? Was it hard to do? Just happen?
It was it was a lot of work, but it really wasn't that hard. I wouldn't say it was difficult, because from all of this customer interaction, I had interacted with customers across a wide range of industries, from the automotive to the mold industry, to people who did plastics design, toy design, gun design, all sorts of processes and design philosophies. And so I had all of these CAD solutions and these ways of manipulating the tool to imitate the process that the customer was trying to create. And so I had all of this information in my head. The book really allowed me to just dump it.
Okay.
And it took about 6 months of working 6 days a week, probably 16 hours a day, to get it all out, because I had to write all the text. And the first book was just under 1,000 pages, I think.
Oh, wow.
And
so it's an encyclopedia, or the beginning of an encyclopedia, right?
Well, it grew even bigger. It wound up being 1,200 pages. But along with that, you have to make sample models, and coming up with models for all of these different situations, and then you have to make big assemblies for your assemblies. You can't reuse data that you just find out in public, so you have to create all your own stuff. And
right.
in some cases, I'd spend a week just making a model, and then a week writing about it.
So is the book, when was it published, and are there additions to it, or are you writing something new?
Well, yes.
Okay. Sorry, you can answer them in any order.
The original book was labeled a 2007 book, so
okay.
I was writing it in 2006, and then there was a 2009, I think, a 2011, 2013 books, but there are also interspaced with those. There was a SolidWorks administration book, which is something nobody had written up to that point, and I think it was something that was kind of rare in the industry. I'd only found one other administration book out there for CAD, and it was really more on the political side. How do you surf the political landscape?
Within a company, that's a big deal.
Yeah, right. It is. But I took the technical route, and I was, how do you get this? How do you want your libraries set up? What are the kind of pitfalls that you need to avoid? And that was one of the, I think, the trademarks of my writing, was that I didn't feel like I was obligated to make the software look good in my book.
Okay. So you were honest about it.
Yeah.
Which is refreshing.
I showed it warts and all, which was it was a good thing for the book. I think it was a good thing for the people that read the book, but it didn't always make me a lot of friends. You can say it that way.
Well, but, Matt, in reading the first quick bio that I got sent, which probably came from Ryan, the question I had, and I think you're going to talk about it here, or at least this is what's reminding me. There's SolidWorks, there's Solid Edge, there's CATIA, there's NX, there's the PDM or PLM behind it all that helps you administer it. You're touching all of that. What nuggets of insight do you have? I mean, the warts is a big deal. I made a hobby unfortunately, out of why I couldn't deploy Teamcenter broader than I wanted inside of a big company like General Motors, right? And part of it was the warts, and we had better point solutions other places, right? And so convincing those users of that point solution to migrate to a more common tool, that was a big deal, as much political as technical. So in your experience, why so many tools, and yet there's still these gaps that lead to administration challenges?
Well, I don't know if this answers the question or not, but I think there's a lot of tension, I think, in the industry between various companies or various CAD producers and between the users of those those tools. I mean, people get very bought into one brand, and they don't want their knowledge to be obsolete, so they really promote that brand. And then even between the companies, you get SolidWorks that has a very different philosophy. I guess I should say Dassault has a different philosophy on how to manage change than Siemens change philosophy. With SolidWorks, you know, they will occasionally just end the lifetime of a particular product. Like
they'll break stuff, right?
You saw that with their PDM, some of their PDM stuff. You see that with their rendering. You know, every couple of releases they get a new renderer or whatever. And now I guess they're trying to do it somehow with CAD, where they're encouraging SolidWorks users to jump to an entirely new product, which isn't going to necessarily have great, you know, there's not going to be a lot of continuity between the products.
Your earlier point about people not wanting to give up the knowledge they've earned, or it's taken them a while to get it, and so they know the way, not so much the engineering process as it is the tool usage process. And then when you show in and you built this trust, and then you come in and you say, hey, I want to change it all to make you even better. Yeah, as long as people are willing to embrace change. Right. By and large, people aren't, right? I mean, and that's to me, that's one of the biggest misunderstandings that developers, the tool developers, that they don't really understand is how hard it is to cross that barrier, the institutional knowledge, if you will. And I say knowledge, it was really important at some point in time, right? And then computers change because they got a lot faster. Your products change, right? And so it's sometimes hard to get past, well, why is this resistance so strong? Sometimes it's because of other things like product changing, right? Or the environment you're selling your product into changing. It had nothing to do with the tool guys, but they tend to be held up as the reason because they're independent, right? You can blame them, right? But,
well, that's interesting, and it kind of flows into the comparison that I make between SolidWorks and Siemens, where Siemens has this tendency. Well, you might remember how they integrated Unigraphics and SDRC. They were able to do that without really alienating anybody. And then even Solid Edge.
Other than time, it took a lot longer than people wanted.
Right. Yeah. But that, I think the time kind of smoothed out that transition even more than they had planned. Also, with Solid Edge, once they acquired Solid Edge added synchronous technology, which is kind of like direct editing, but they did it in such a way that the existing customers didn't have to give up anything. I mean, you talk about disruptive technologies, you try to put together history-based modeling and non-history-based modeling, and you'd think that would be like oil and water, but they found a way to really integrate them in a way that allowed both types of workflows to happen at the same time on the same data, with the same users. Right. And now they've gone and they've added. You've got. I'll think of the name here eventually. No, I've got this written down somewhere.
Well, to your point, they've expanded without breaking a bridge to the past, and that is one of their hallmarks. That, as much as we got frustrated and we pushed, the reason we stayed with them was that, right? And over the years, at my experience, and now they're with their acquisition of the guys from the EDA side, electronic design automation,
right?
I'm looking forward to more and more. It's been interesting to watch. So. Well, maybe go ahead. I'm sorry.
Sorry. Convergent modeling was the word.
Oh yeah, right.
So they've integrated both synchronous technology and convergent modeling, which is dealing with point-based type data. They've created these two completely different workflows, and they put it inside the same tool that works with their history-based modeling. And so you can put all three technologies together into a single data file for a single part. You can mix them in assemblies. And so I think even though I do most of my work with SolidWorks tools, I think that the Siemens and Solid Edge philosophy of bringing together various technologies is it's much more robust. It's much more user friendly because they're not alienating people as they add technologies. They're bringing that all together.
Yeah. So you mentioned early on, and you emphasized the word design. Could you elaborate on that? Is design a industrial design? Is it a technique? Is it sketching, or is it something completely different?
Well, I have a blog, and I write a lot about the difference between design and modeling.
Okay.
Quite honestly, what I do mostly is modeling, but I will sometimes be called into a situation and I've got to put on a design hat. A lot of times I'm working with an entrepreneur or an inventor, and they've got a product. They know what they want it to do, but they don't know how to physically get it there. Or sometimes somebody has something that physically works, but they want to make it look better. So my background is in engineering, and I feel like I'm a pretty technical guy, but I've got this background, this artistic background, and I'm not claiming to be a visual artist or an industrial designer, but I do have a little bit of that bent. And I think mechanical engineers, at least if you're involved in product design, you need to have a little bit of an eye for the aesthetic. And,
and I'm glad you went there, because a lot of commercial products, from cars to soap bottles and everything in between. Even a John Deere tractor in your backyard.
Right.
There's an aspect of it that's all about beauty and attractiveness and so on, and not a darn thing to do with engineering integrity, right? How long it'll last and all that. And both are important, right?
Right. Yeah.
In the car business, it's all called the Class A surface, and we hire. It was funny. I got this job in GM, and we hired designers to make sketches of beautiful products, and eventually make a clay model, and eventually engineers put stuff behind all that to make it crash worthy, right?
Right.
But at the end of the day, it's not an engineering thing that you plaster some sheet metal on. It's quite the opposite. It's a sheet metal structure that will sell well, that'll be great in commercials, all that other stuff, and you engineer behind it, right? So industrial design or aesthetic design is not necessarily engineering design. Now, when you can combine the two, well, that's really cool.
Right. And part of combining the two for me was that a lot of times the type of data that I got was I would get an industrial design sketch or an industrial design model, something made in sub D that you really couldn't use for engineering purposes. And I had to make a NURB surface over it. And so that's, I think you need an aesthetic eye for being able to imitate the shape that you've been given and try to make it, you got to add some draft to it here and there. Do it in such a way that it really doesn't violate what the industrial designer intended for that design.
And then hopefully you can manufacture it efficiently, at least if you're making thousands of them, right? So interesting. So there's new technologies coming in manufacturing, like additive manufacturing. This ability to print a part rather than mill or bend a part. Is that changing the way design practices work? And what's your view of that?
I think it is. Whether it's been valuable or not, I don't know. But I've spent a lot of time in the last year writing some articles about point-based data and how it's becoming more and more important to the mechanical engineer. We've always, for the last 30 years, we've had the STL file type for stereolithography. We've done 3D printing from that, and it's just the materials have evolved over time. But so that's one point-based data that engineers have been comfortable with, but we could never take that information back in. We could never edit it. Then we had meshes that we would work with from, say, doing an FEA analysis. You're going to do a stress analysis. You have to mesh that. That's all point-based data. Then 20 years ago, there was Pixar, and they came up with this this subdivision modeling kind of thing. And engineers have just held that at arm's length, because you say, that's the line. That's artist stuff. That's the things for
industrial design. We don't do that, right?
Right. Yeah. So, but now there are tools like NX and I'm sure CATIA and even Solid Edge now and Rhino and Fusion 360 that have SolidWorks has an add-in with power surfacing, it's called. Where you can do subdivision modeling inside your NURBS modeler. And so I think that's I think this is all a direct result of 3D printing becoming so popular, and the fact now that we're also seeing a lot of 3D scan data, which is all point-based data. We're seeing
that's a good point. People are scanning old factories, right, to do better modification of factory. It's an interesting development,
right? And we're reverse engineering parts by scanning them. I got a project I'm working on right now where I got a 3D scan of a part that the mold has fallen apart, and they don't have electronic data to make a new mold. So I have to do surfacing over the 3D scan. And also we've got MRI data and CAT scan data, so we're integrating all the medical type information for prosthetic parts for people and organs, I suppose, and all sorts of applications there. So the point-based data has really come into engineering in our engineering tool set. And go ahead.
Well, and do engineers, mechanical engineers, aerospace engineers, structural engineers, do they get it? Are they comfortable with that, or do they want to go back to, let me go build one and put it in a lab and break it, or something like that?
Yeah, I think it's, I think the jury's still out on that. It might be the
might be an age thing, right?
Yeah, it might be that. And it might be the kind of thing that takes a lot of retirements in 20 or 30 years for.
Well, that might be happening right now.
Yeah, but also there's another part of it that I appreciate, is that we've got this new thing called generative design. It's been around for a few years now, and this is all point-based data. It's optimization. It helps you get you can optimize for strength or weight or something, but inevitably the product out of this is something organic looking, and this creates more swoopy shapes. So a lot of times the swoopy shapes are stuff that just can't be produced through your average manufacturing methods. So
yeah, you can't mill it or bend it, so you don't do it.
Yeah.
Right.
But and beyond the shapes, it also allows us to do things like internal cavities and even internal meshes for a reduced density part. Even if the skin of something is solid metal, the inside of it could be a mesh to reduce weight. So yeah, I think I think it takes time for these things to go anywhere further than some nice screen captures in the marketing department. But I think it's there, and I wish a lot more people were taking advantage of these types.
Well, I think the thing to watch is you go to the big conferences. Of course, they're all virtual at the moment with the pandemic. But the amount of people trying a trial run with some sort of manufacturing run with printed parts, you know, in the car business, it'll start with performance parts and replacement parts, right? Before it becomes mass produced parts. But mass production's in our lifetime for sure for cars. So 100,000 units a year out of a plant, right? So that's interesting to watch. You know, I before I let you go, we've been, you know, given our times, we've been asking people, how has the pandemic affected your work? As an entrepreneur and as an author, has it affected it at all? Or are you just doing what you've always done?
Well, I've worked at home for the last 17 years, so it hasn't affected my professional life hardly at all. I'm still doing work for people I've never met. But what it is affecting is, you know, because I work at home, I have to have some sort of a social outlet outside of work, and so that's been, if you can guess, music.
Yeah.
But
cool. Back to your roots.
It all goes full circle. That's what I like.
But the problem is that even music is been affected by the pandemic, and you can't get together with 100
you can't do it live. You can do it Zooming maybe if you're really lucky, but that's hard.
We have got a couple people together, played under a gazebo outside. That's been fun, but you know, it's pretty difficult. So my social outlet now is going on Tuesday mornings to get a McDonald's breakfast and bring it back to my wife. You know?
Well, that's interesting insight, and I think we all, you know, I do these home projects in semi-retirement, and early this morning I went and got some parts to finish a project at the lumber yard. Right, we're all masked up, and you know, everybody's trying to follow the rules, and so, or at least the advice. So it's been interesting. Yeah. Well, Matt, it's been a joy to chat with you, and please keep up the good work and give us advice going forward on how to do great industrial design along with these tools. I appreciate the insight. Tom, back to you.
Yeah, Matt, before we let you go, you know, I was listening to sort of your story, and I love people who have kind of unique and eclectic stories, because we all do. And so many people think, oh, my life is, you know, just my life. But, you know, I mean, you kind of had an interesting way. But, you know, when you got to write this book and then you started, you know, with your blog and other stuff, you've clearly positioned yourself as an expert in your field. And we talk to a lot of people who are trying to grow their careers, and whether or not they want to write a book or have a blog, one of the advice that comes up over and over again, and I'm paraphrasing this, is, you know, become good at what you do, be that expert. So what advice do you have for people who are like, how come he gets to write a book? Or why does he have a blog? And the advice is position yourself as an expert. What would you tell them?
I would say a couple of things. You can plan and make goals, but don't underestimate the value of opportunities that appear unexpectedly. I don't think I would have even thought to have planned to write a book about engineering, about an engineering topic. So I just kind of fell into that by accident. And if I had been laser focused on a particular plan or a goal, I wouldn't have done that. So that's one thing I'd say. And another thing is take this whole idea of you can do whatever you want to do or just do what you're passionate about. Take that with a grain of salt, because I was very passionate about music, but I found that it was not a good way to make a living. You know, it's okay if you don't mind sleeping on somebody's couch for the rest of your life, but take an aptitude and interest test that's available from your state employment agency. Find out the things that you're naturally good at, and those tests will probably just confirm something that you already know, and then try to align those the things that you're good at with a field that you're interested in, where you think you can spend time working. I don't think I could work in a field where I was very passionate, because I'd just be in too much trouble. I'd be too opinionated. I'd be too I'd just cause too much trouble. So
well, you're just saying you're anti-political, right? But, which, by the way, might be good. I don't know. Some too much. Well, then again, not today. Whatever. Go ahead. I'm sorry, Matt.
So, anyway, I think there are some things that are better left as hobbies, and I think the things that you're very passionate about, you're going to, if you use it as a hobby, It's going to be a lot more flexible. You're going to be able to do what you want to do. But if you're trying to do work in that area, then somebody else is probably going to be telling you what you can do. And that's something to avoid.
So that's actually kind of interesting. I started my career as a professional photographer, and I loved photography. It was, I always had a camera with me in high school and college and all this stuff. And then after photographing about 100 to 150 weddings, the technology changed. I didn't pursue it. I walked away from it, but I rarely carry a camera. I mean, it's on my phone, I guess, but I rarely go out to take pictures anymore because that passion and that hobby became work that was kind of a pain in the ankle. And so,
Right. Yeah.
so I sort of get with where you're going with that. But your first piece of advice, I just want to hit it again because I think it's so true. You can plan and you can try and you can go and you can have goals. And I'm a huge goal setter, big believer in it. But at the same time, there's something about serendipity, isn't there?
Right. Yeah, that's great.
So, Matt, thank you very much for joining us here on the Digital Enterprise Society podcast. For everybody who listens, please come back every single week. Craig and I do this for you, and every week we're trying to bring you more thoughts, ideas, and information in and around product lifecycle management. The Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out right now at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.